In today's video, we're going to look at right triangle trigonometry. We're going to look at three main goals. By the end of the video, you should be able to evaluate the 6 trigonometric functions of acute angles of right triangles, use your calculator to evaluate trigonometric functions, and to use trigonometric functions to solve real-life word problems or situations. So, to start, let's talk about the right triangle definition of the 6 trigonometric functions. These should be very similar to what we've done before, but this is slightly different terminology. So, the terms we're going to use to define how to find sine, cosine, tangent, cosecant, secant, and cotangent of angle theta, which I'll label as this bottom acute angle of this right triangle I just drawn, is going to use our sides of our right triangle. Now, the key with this is you look at the side opposite the angle theta. So theta is what we're trying to find, sine of theta. We want to look at the side opposite, and that is called the opposite side. So it's the leg, and leg by definition is one of the sides of the right triangle that forms the right angle. So this is a leg, and this is a leg of the right triangle. The side opposite the right triangle, the right angle of the right triangle, is called the hypotenuse. So this is the hypotenuse side because it's opposite the right triangle. Okay, so the leg opposite angle theta is called the opposite side. The leg adjacent to angle theta, so notice how this bottom leg is touching angle theta, is called the adjacent side because it's adjacent to angle theta. It's one of the rays that form angle theta. And the side opposite the right angle is always called the hypotenuse, and it's always the longest side of the right triangle. So that's how you identify your sides of your right triangle. Now, our formula is, in order to find sine of theta, we take our opposite side, we divide it by our hypotenuse. It's a little thick. Our cosine is our adjacent side divided by our hypotenuse. And tangent is found by taking our opposite side divided by our adjacent side. And then, of course, cosecant, secant, and cotangent are our reciprocal identities. So to find cosecant, I'm going to take 1 over sine, so 1 over opposite over hypotenuse. Flipping that bottom fraction becomes hypotenuse over opposite. And secant of theta, therefore, has to be our hypotenuse divided by our adjacent. And cotangent of theta is our adjacent divided by our opposite. Now, there's many ways that you can use to kind of memorize this. Most common method you will see is Shakatoa. That's taught by a lot of people. When I was a student, Shakatoa was not very helpful for me because I could never remember how to spell Shakatoa. I could say it, but I couldn't remember how to spell it. And so I'd still get confused. So I came up with a little saying of my own, and I highly suggest that if this is something that might help you remember it, you can come up with your own saying. But at that point in time when I was in high school, I was showing I was doing bear racing with horses, and I really loved horse riding. And so I remembered it this way. Some old horse caught a horse taking oats away. And that's how I remember it. And everything on my test, I would just say that saying in my head. Some old horse caught a horse taking oats away. And I would always remember my correct ratio of my right triangle trigonometry. So you don't have to come up with that saying. It might not make sense to you. You're maybe not into horses, but whatever makes sense to you, come up with a saying that works, and so that you can remember the ratio of this. So let's see how we can apply this in a problem. So here on this right triangle I got drawn over here, we are asked to find the sine, cosine, tangent, cosecant, secant, and cotangent of theta. Now, I've only labeled 2 sides in the legs of the triangle. So I have the side opposite angle theta is labeled as 4, so that's going to be my opposite side. The leg adjacent to angle theta is my adjacent side, and I labeled it 3. But our hypotenuse, which is opposite the right angle, has not been measured. So to find the hypotenuse, we're going to use Pythagorean theorem. X squared plus y squared equals r squared. Okay? Or in this case, h squared. So in the case of this, we can think of it as our adjacent side squared plus our opposite side squared is equal to our hypotenuse squared. So our adjacent side is 3, our opposite side is 4, and the hypotenuse is what I'm trying to figure out. So it gives us 9 plus 16 equals hypotenuse squared. That's 25. Square root of 25 is 5. So our length of our hypotenuse side is 5. So find sine. Remember, sine is equal to opposite. Let me write that correctly. Sine of theta is equal to opposite over hypotenuse. So our opposite is 4, our hypotenuse is 5. So our answer is going to be 4/5. Cosine of theta is adjacent over hypotenuse. And our adjacent side is 3. Our hypotenuse is 5. Tangent of theta is equal to opposite. So tangent of theta is equal to opposite over adjacent. So our opposite side is 4. Our adjacent side is 3. So once you get those main 3 trigonometric functions, you can always find the other 3 by using your reciprocal identities, flipping it over. So if sine of theta is equal to 4/5, cosecant of theta is 5/4. Secant of theta must be 5/3, and cotangent of theta must be 3/4. Okay. Now, for this next example, I'm looking at the same right triangle I have drawn up here, but I wanted to find the 6th trigonometric function of alpha. So now, alpha is the angle that I'm focusing on. So since alpha is the angle of focus here, it's going to change which is our opposite and which is our adjacent side. So opposite angle alpha is side 3. So this is now, I said it and was right in the wrong one, is the opposite side. So that's the opposite of angle alpha. The leg adjacent to angle alpha is 4. But the hypotenuse does not change based on which angle you're looking at. That is still going to be our hypotenuse. Now, if it helps you, I would suggest that you label your sides when you're working a problem, but that's not required. So sine of alpha is going to be my opposite over my hypotenuse. And our hypotenuse, this still right triangle is still 5, so our hypotenuse is 5. So that's going to be 3/5. Cosine is going to be our adjacent, which is 4, over our hypotenuse of 5. And tangent is going to be opposite, which is 3, over our adjacent side, which is 4. And the reciprocals, of course, flips over. Now, notice something cool that happens in these two with theta and alpha, the 2 acute angles of a right triangle. Notice that our, I'll go to that in a second. Okay, so notice that we have our sine of alpha, which is 3/5, is the same as our cosine of theta. Sine of alpha equals our cosine of theta when we're looking at 2 acute angles of the right triangle. And similarly, cosine of alpha, which is 4/5, give us the same measure as our sine of theta. And our tangent of alpha, which is 3/4, is the same measure as our cotangent of theta. And that's cool. This always happens with the 2 acute angles of a right triangle. And the reason for that is called the cofunctions of complementary angles. Now, since this angle, the right angle of a right triangle is 90 degrees, and I know all angles of a right triangle add equal 180, I know that theta and alpha must add equal 90 degrees. So they are complementary angles. Complementary angles are any 2 angles that add to equal 90 degrees. So theta and alpha are complementary angles. They add equal 90 degrees. And so what our cofunction of complementary angle says, I can replace, if I solve this equation here for alpha, I got alpha is equal to 90 minus theta. So I can go up to these, what I have written up here, and I can replace alpha here with 90 minus theta, or pi over 2 minus theta, whichever way you want to write it. So sine of 90 degrees minus theta is equal to cosine of theta. And likewise, I can replace this alpha here because I've solved alpha to equal 90 minus theta. 90 minus theta is equal to sine of theta. That right there is called our cofunctions of complementary angles. So sine of 90 degrees minus theta is equal to the cosine of theta. Cosine of 90 degrees minus theta is equal to sine of theta. Tangent of 90 degrees minus theta is equal to cotangent of theta. Cosecant of 90 degrees minus that is equal to secant of theta. And this just comes from the switching of the sides, the opposite and the adjacent sides on our right triangle that I showed you before, based on which angle you're looking at. And it's cool that these work in any complementary angle set. And secant of 90 degrees minus theta is equivalent to its cosecant of theta, and the cotangent 90 degrees minus theta will give you the same measure as tangent of theta. So using our cofunction identities, we were given that the cotangent of theta is 5. So we want to find the cotangent of theta, pi over 2 minus 5. So pi over 2 is just 90 degrees, just written in radians this time. And so I remembered that cotangent of pi over 2 minus theta is equal to our tangent, or alpha, sorry, is equal to our tangent of alpha. Okay, so I'm using this identity right here as using the tangent of alpha, okay? So if I was given that cotangent of alpha is 5, then tangent, which is a reciprocal, identity of cotangent, which is 1 over cotangent, must be 1 over 5. I can flip it over. So therefore, I can conclude that cotangent of pi over 2 minus alpha is 1/5. So just kind of putting that together. Okay, for the word problem section that we're going to be using, you're going to be allowed to use your calculator for these because you can get some really large numbers to worry about and not perfect angles. We're going to get off of the unit circle. So I want to introduce now how to find the 6 trigonometric functions using your calculator. And if you're given what the trigonometric function, like sine of theta is equal to x, or equal to like 0.5, how do you find the measure of angle theta? And that's what we're going to learn in the next section. Okay, so first thing you want to do when you get to your calculator, and please get your calculator out that you'll be using so you can do this work with it. First thing you have to do is make sure that you are in the correct mode. Every calculator has 2 modes. It's either radians or degree. And you need to be able to figure out how to switch between radian degrees and degrees to radians using your calculator. So make sure you can identify your mode in your calculator. So that's the first thing. Always check. Make sure you're in correct mode. You'll get an answer that if you're in the incorrect mode. And then for sine, cosine, and tangent, they have those buttons on your calculator. So we can just click those buttons easier. But if we want to figure out cosecant, secant, or cotangent, we're going to have to use our reciprocal identities in order to type this in on our calculator. So basically, if I want to find cosecant of, say, 30 degrees, what I will type into my calculator is cosecant is the reciprocal of sine. So I would type in 1 divided by sine of 30 degrees, because those are our reciprocal identities. And if you're asked to find secant of alpha, that's going to be 1 over, and secant is reciprocal identity of cosine, so 1 over cosine of alpha. And you're asked to find cotangent of alpha, that is going to be 1 over tangent of alpha. All right, So what I want you to do now is go to your graphing calculator. Okay, here's a TI-83, I think. It might be 84. But this is my graphing calculator that we're going to use. And so very first thing is you're going to find your mode. So for this calculator, our mode is just found right by that blue second button. And you can notice that I can be in radians or degrees. So depending on what your situation is, you need to make sure you're either in radian mode or in degree mode. The switch, all you do is highlight it and push enter. So this calculator is now in degree mode. If I want to go to radian mode, I go to radian, push enter. Okay, so that's how you switch your modes. Now for the first example, I think it was, let's find cosecant of pi over 8. So first off, that's reciprocal identity, so that's going to be 1 over sine of pi over 8. So that's what I'm going to need to type in my calculator. Pi over 8 is obviously in radian mode. So I need to make sure my calculator for this example is in radian mode, which I am in. Okay, so one thing to do 1 over on these calculators, you can do alpha y equals, and that gives you a fraction. Okay, so I'm going to do 1 and move down to the bottom of the fraction. And I'm going to push the sine button. And then my pi button, which is second caret, divided by 8. And then get out of the fraction and push enter. Okay, so this is the answer, and we round this to 4 decimal places, I think the instruction says. So I'd write 2.6131 as my answer. And that's all you do. That's how you find it using your calculator. So now I have sine of 76.8 degrees is what I need to find. So go back to my calculator. I need to go, this is in degree, so I need to go back to my mode, cursor to radian and change it to degree, push enter. So I'm now in degree mode. And I'll hit sine, and I want it to do 76.4 and enter. And that is what the sine of 76.4 is equal to. 0.97196, but it asked around to 4 decimal places. So you look at the fifth, which is the 6, and round that up. So I would write my answer to this one as 0.9720. Okay. Now this last one is asked to find cotangent of 1.5. Well, cotangent is another reciprocal identity, so that's going to be 1 over tangent of 1.5. Now notice, 1.5 here has no degree symbol. So this is 1.5 as radian. So this is in radian mode. They just have done the pi, that 3.1415, etc. They've actually calculated it out. So this is just 1.5 radians. So if it doesn't have a degree symbol, you know it's radians. If there's no notice of what measurement it is, especially if it's a number without a pi in it. So I'm going to do, so I'm back into radian mode. So that's the reason why you always have to check your mode. I'm going to go over mode, and now I need to go back, whoops, went too far, to radians and change off of radian, quit. Okay, and so this time I asked to do cotangent. So that was 1 divided by tangent of 1.5. Enter. And so I get 0.0709 is what that would be to 4 decimal places. So we have 0.0709. And so that's how you find the 6 trigonometric functions using your calculator. All right, let's apply this to a word problem situation. So a surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree as 71.5 degrees. How tall is the tree? So this is kind of a standard type of application problems for right triangles. We always assume that trees grow straight up and down, and the ground is always flat unless specified otherwise. So there's basically, on solving any of these word problems, there's going to be a 4-step process. First step you want to do is you need to draw the diagram of what's going on. So draw a picture of what's going on, And make sure you clearly label that, especially label any of the unknowns so that I know exactly what your variable that you're going to use in your equation for the next step represents. It has to be labeled on your graph, on your diagram, or you don't get credit for setting up your equation because those variables will mean nothing if I don't know what it goes to. So I have a nice pretty tree. So here's my beautiful tree, and this is my beautiful ground. And a surveyor is standing 50 feet from the base of the tree. So this is going to be 50 feet. So notice I labeled that, units and the length. And I want the surveyor measures the angle of elevation to the top of the tree. So from the ground to the top of the tree, and this is that right there, that's our angle of elevation, is 71.5 degrees. And then what I want to figure out is how tall is the tree. So this height here is my x. That's what I'm trying to find. So there's all I need on a diagram. Now you don't even have to draw the tree. You can just draw a line there to represent your tree. But that's basically what you need for step one. Draw the diagram and label everything. Label what you know, label what you need to figure out. Okay, now I got to set up a trigonometric equation for the data. So look at this. You're given two sides of the triangle and you're given an angle. So if I'm looking at this angle here, this angle of 71.5 degrees, and I identify the sides that I were given here, I'm given this side, which is my opposite the angle, and then I'm given this side, which is adjacent leg to the angle. And you ask yourself, which of those trigonometric functions, and easily, if you go to the first three, it's the easiest, because they're easier to do in your calculator. Sine, cosine, tangent, we have those buttons, our calculator. So which of the three trig functions, sine, cosine, tangent, involves the side opposite and adjacent? And that would be tangent, because we know tangent of theta is equal to our opposite side over our adjacent side. So to set up our equation, I would say, okay, tangent of 71.5 degrees, that's the name of that angle, the measurement of that angle, equals our opposite side, which is x, our adjacent side, which is 50. That is it. You've made your equation for this situation. Now I'm going to take this equation and I'm going to solve for x. So I notice what's happening x. I'm dividing x by 50. So the opposite of dividing by 50 is multiplying by 50. So I'm going to multiply each side of the equation by 50, and I end up with 50 tangent of 71.5 equals x. All right, so now I'm going to go to my calculator and figure out what 50 times tangent of 71.5 x is equal to. So I need to check my mode. I am in degree mode, so I need to go up here and put it in degrees. Make sure you check your mode every time, because we will be switching back and forth. All right, so now I need to figure this out in my calculator. So I'm going to type in on my calculator 50 times tangent of 71.5. Enter. And there I get my answer. Now, unless it specifies otherwise, usually in these word problems like this, 1 decimal place or 2 decimal places are plenty. You don't have to go to 4 decimal places. We're not ever going to get that measurement. So I'm just going to go to 1 decimal place. So 149.4. Okay. So 194.4 feet is my answer to this. So our last, I guess I should put that here. Our last step that we do is, now that we found the answer, I want you to communicate that answer into sentence form. Now, the reason I do this is I make sure that you've read the problem and you've answered the question that was asked, and that you have included your units of measurement, or important. So the question says, how tall is the tree? So all you have to write is the tree is, since I've rounded, I'm going to put about 149.4 in my units of measurement. Go back up here and I notice feet. And you're done. So the tree is about 149.4 feet. Now, what if the angle is missing and you were given the two side measurements? So to find the missing angle, you're going to need to use something called inverse trig functions. Now we're going to have in later sections, we're going to go a little bit more in detail on that. But for right now, basically what you need to know is just like inverse functions you learned in college algebra, inverse trig functions switch your domain and your range. So you're switching those values. So if I had, say, sine of theta is equal to y over r, okay? So that's our sine of theta. Now, if I wanted to solve this equation for theta, get theta by itself, you would use the inverse trig function, the arc sine, or the inverse of sine, switch your answer in what's inside the trig function. So that's it. That's inverse trig functions. So this symbol here, this symbol here is read two ways, okay? Inverse of sine. So I could say the inverse of sine, y over r is equal to theta measurement, theta. Or, and this is the way I tend to read it, the angle whose sine is y over r. Okay, the angle whose sine. And there's a second notation I also interchange use. The sign, the sign with the -1 exponent, the inverse of sine, that kind of uses that inverse notation from functions. And also that's the notation they use on the calculator. But a lot of trigonometric textbooks, professors, people in pure study of mathematics, and even some businesses like surveyors and stuff, some of them prefer to use the arc sine, because that just reinforced the angle whose sine is whatever measurement. So you would often see it as arc sine. I will be using these symbols interchangeably, so be able to recognize they mean the same thing. And this is true for all trig functions. So if I want to find the angle whose cosine is, I don't know, 1/2, what I would write, you would see that would be written as either cosine inverse of 1/2. I'm going to figure that out. Or it would be written as arc cosine of 1/2. So those notations will be used for all trigonometric functions. All right, so here's a word problem that requires us to use these inverse trig functions. Oh, and your calculator, again, only has the inverse trig functions for sine, cosine, and tangent. So if I wanted to figure out the arc secant, not theta. So if I want to figure out what your arc secant of something is, then you would type into your calculator 1 over the inverse sine, or your arc sine of x. Or arc cosine. I did the wrong one there. Sorry. Gotta caught myself. Cosine of x. Okay, and so if I wanted to find the inverse cosecant of x, that'd be 1 over the inverse of sine of x. Okay, and then the arc cotangent of x is 1 over the inverse tangent of x. Okay, so those are the ones that are arc tangent of x. All right, so looking at our next example here, a 12-meter flagpole cast a 9-meter shadow. Find the angle of elevation of the sun. Okay, so I'm going to go through the 4 steps as I work through this. Okay, so draw a diagram and layer the diagram. Okay, so I got a flagpole here, and I know this flagpole is 12 meters high. It casts a shadow, which is 9 meters. So if this is the shadow, that means my beautiful sun has to be over here in order to get a shadow that's going in this direction. So if I want to find the angle of elevation to the sun, I'm going to be going up here to my sun. Okay, so that's going to be my angle of elevation. I'll label it theta. So that is what I'm trying to figure out. I'm trying to figure out angle theta. And there's our right triangle. So here's a basic one. Notice I didn't draw a pretty picture of my flagpole. You can draw a flagpole if you want to. You can as detailed as you want, but that is the bare minimum that you need. Well, bare minimum you need is this. Okay, so that's my first one. I got my unknown and what's labeled. So second one, again, I'm going to set up an equation using what's known and what's unknown. So I know I have this angle theta, and I know this side and this side. So angle theta here, 12 is going to be my opposite side of angle theta, and 9 is my adjacent side. So what trig function involves opposite over adjacent? That's tangent again. So tangent of theta is equal to my opposite side over my adjacent side. So this is my setup equation, but I need to solve for theta. Theta is what I need to get by itself, but it's inside a trig function. So the only way I can do that is using inverse trig operations. So I would say the inverse of tangent, and then switch our domain and range, of 12 over 9 is equal to theta. I've now solved this equation for the unknown, for theta. Okay. Now, this word problem doesn't say if I'm in degrees or radians. When we're dealing with word problems like this, when you're thinking about the angle of measurement, angle of elevation, angle of depression, any of those, you're going to assume you're in degrees unless stated otherwise. So it's one of those weird ones that are assuming you're in degrees. So I'm going to go to my calculator now, and I'm going to type in this arctangent of 12 over 9 and get our measurement in degrees. So go to our calculator. And so again, I need to make sure my mode is in degrees. So degrees are highlighted. I'm good. And so I'm going to type in my inverse tangent. Now to get to that, I'm going to hit second and then tangent. And notice it gives me that tangent to the -1, that inverse tangent. And then in that, I'm going to do 12 divided by 9 and enter. And that's 53.1301, etc. degrees. So again, 1 or 2 decimal places, usually 2. So I'm going to write this as theta is equal to 53.13 degrees. And then your final step, translate that to a sentence, find the angle of elevation of the sun. So the angle of elevation of the sun at this given time is 53.13 degrees, or is approximately, you can write, or is about 53.13 degrees. And that's it. And that's how you do right triangle trigonometry.